I forgot about that, and I also like really didn't remember about like if you get it wrong, it's negative points.
Yeah, although
so
that doesn't really affect things if you think about it. It is negative points, but the chance of you guessing correctly completely counterbalance the negative points that they're going to take off.
Yeah, that's true.
Now you're a junior. They're actually changing that in 2016, I think, on the SAT. Maybe 2015, but they're going to change it so they don't take off for wrong answers.
Ooh.
That might be 1 year too late for you.
Yeah.
Not sure it really matters because it's all relative anyway.
Yeah, it wasn't too hard, I think.
Good. Well, your math skills are pretty good. I would expect you to do pretty good on that. You were always scoring well on the ACT as far as that goes.
Yeah.
So what are you working on in class now?
Let me get it. We didn't really have class almost all last week because of we had a bunch of testing, so that was a problem. I was thinking it was just because my mom wants this to be more based off like ACT kind of stuff for the next maybe a week or so.
Okay.
So, do you still have that download by chance?
I do. Question is, I think I know where, in fact.
I can resend you it if you want.
Yeah, hold on. Let's see if I can find it real quick. That was this one right here, I believe. Correct? Can you tell?
That looks right.
Yeah. Now the question is, how far did we get through it?
Let me see. I wrote. Let me look where we ended.
Yeah, I think I wrote also. Let's see. No, I don't have a note here with your name on it, unless I have it in the McGraw-Hill. I also have a bunch of ACT tests that we haven't done yet.
Okay.
I've got plenty we can draw on. So we don't have to do that document, but we certainly can.
Yeah, it's extra credit for math too if you finish it all. So
okay.
I have another week.
Well,
I have a week to do it, so why not?
Let's look at it. Yeah. Did you figure out where we got to?
Yeah, let me turn the page a little. Okay, so I think we actually ended on. Let's see.
I don't think we got very.
I think we got to 20. No. There it is. I think we got on to 22. That's when we ended. Because I remember the which of the following equals, and then that's when we ended.
Okay.
Yeah, 22.
So we finished 22. Let's start with 23.
Okay. Anderson has a phone that plans a church. Oh, wait. Did we do this one?
I think we did this one because this one was a little tough.
Yeah.
Tough coming up with the 1,000 minus n.
I found that page. There it is.
Yeah, we did do that one.
I think I skipped a page when I was turning.
Well, but what about 24?
I think 20. No, I think that's where we stopped.
24 is a good one to start with, because no matter what, 24 is one of the most basic things you can know in algebra. So you want to make sure you know how to do 24.
Okay. So the intercept of the line that passes through 3, 4, and has a slope of 2.
Well, actually, I didn't read it totally when I said that. The thing you absolutely need to know is how to come up with the equation of a line through a point with a given slope.
Line through a point with a given slope.
Which they ask for a little bit more here. But if we can come up with the equation of the line, then I'm sure you can figure out the x-intercept.
Yeah, let me figure it out. So if it's the slope of 2.
What's the next step at this point?
So if it's Oh, sorry. Okay, so if it's 2x plus b, we can't really find a y-intercept just yet.
Actually, you
Unless...
can. In other words, once you plug in 2 for m,
Mm-hmm.
now you have this equation here. They're giving us a point. So let's plug that point in for x and y, and we will be able to calculate b.
Okay. So we can plug in 3 for x, and then 4 for y. So 4 equals 2 times 3 plus b. Negative 2 equals b.
Okay, so now this is the equation of that line.
Okay.
All right, now how do I find the x-intercept?
Well, you can just use that equation.
Okay.
And then, what I would usually do is just use that equation, and then by using the slope, I would just calculate the slope and just do that.
There's a better thing to know, and that is that the x-intercept comes when y is 0. And the y-intercept comes when x is 0. Those two things right there are critical in a lot of math, is to know both of those things. So if y has to be 0, then I can set it equal to 0 and solve that.
So it'd be y equals x equals 1, yeah. Oh, that's a lot faster than I would have done.
Well,
I
understand what you were saying in terms of using the slope to back up to the x-intercept. But it's well worth knowing that the x-intercept is when y is equal to 0, and the y-intercept is when x is equal to 0.
Okay, yeah, that's a lot faster too, I think. Okay. Alright.
Okay.
So 25.
25 and 26 both refer to that graph.
Okay. So it's saying, okay, which of the following pairs of authors received exactly 30% of the votes altogether?
Yeah, and on a question like this, Anthony, I would always read the question before I even looked at the chart and tried to figure it out. Because, they may ask you, you could spend time trying to understand the graph, and if you didn't know the questions, it would be a similar tip that a student once gave me on the science part of the ACT, which was read the questions first before you read the passage.
Yeah, that was a big problem we had in the SAT for the critical reading. I read the whole story and then went to the questions, and none of them really referred to the whole story in general.
Yes, I think it makes sense to do the other way around.
Yeah.
All right, so let's read the question.
So which of the following pairs of authors received exactly 30? So together. So it would look like Tony and John. So D. I think, yeah. 20 plus 10.
Good. And 20, see, that was relatively quite easy.
Yeah.
26.
So 26, if it's actually 260 people voted, how many votes did Cormac McCaffrey receive? So, I don't know if I should use a calculator, but you just do 15% of 260.
Yeah, that's all you do.
And then you get that answer.
A quick way to do 15% of a number is to do 10% and then add half of that.
Oh.
In other words, 10% of 260 is 26. Half of 60 is 13, 100, or 26 and 13, so 39 is.
Yep. Okay. Yeah, that's nice to know. Okay. So 27. So So the graph doesn't refer it to, or that, okay, it doesn't. Okay.
No, I think there's...
No. Okay, so Annie and Catherine are both saving money for jobs to buy bicycles. Annie has 150 less. She would have exactly as... Annie had 150 less. She would have exactly 1/3 as much as Catherine. And if Catherine had twice as much, she would have exactly 3 times as much. How much money have they saved together? So...
Notice what this problem is not, and what I thought it was when I first read it. When I first started reading it, I says, this is a marble problem or an age problem, which are all best solved by back solving.
Mm-hmm.
This is not, because the final question says how much money have they saved together. So if I were to guess and start with $400, that doesn't really leave me anywhere.
Yeah.
You can't take this answer and work through the problem and see whether everything would be true. Not at all. So I may have to solve this algebraically.
I was thinking of making an equation.
Okay. So how do you start a word problem if we're going to solve this algebraically?
I was thinking, since she had like 150 less, and that would have been 3 times more than Anne, then I would think it'd be, I would call A equals Anne, I think, and K equals Catherine. So.
Okay, so that's the place to start, is define your variables.
Okay.
Anne is the amount of money, the amount that Anne had, and K is the amount that Catherine had. So now let's see if we can put together some equations with A and K in them.
Okay, I was thinking of, no, I'll factor it after, or FOIL it after. It's 3.
The first sentence is meaningless.
I think
doesn't help. Let's start with the second sentence. If Anne had 150 less, she would have exactly 1/3 as much as Catherine. Put that into an equation.
Okay. Oh, okay. I did a little flip around. Okay. So if she had 1/3 as much as Catherine.
Start with the first part of the sentence. If she had 150 less, how can I write that?
So A minus 150.
Okay. That would be equal to 1/3 Catherine, correct?
Yeah, you could say that.
There's this very straightforward equation.
Okay.
What's the second equation? Because we got 2 variables here, we better have a second equation, otherwise we can't solve it. Well, the second equation comes from this middle sentence. So what would that equation be?
So the middle one? And if Anne had twice as much.
If Catherine had twice as much.
Oh, yeah, sorry. If Catherine had twice as much, she would exactly have 3 times as much as Annie. Okay, so that's a little weird. Okay. So if she had 3 times as much, she would exactly have... Wait.
Go with the left.
She has twice as much.
Go from left to right, not from right to left.
Yeah. Okay, so 1/3 as much as Catherine. And if Catherine had twice as much, she would have exactly 3 times as much as Annie. Shit.
So what's twice as much?
Or you could say...
K equals
2K.
Exactly.
Equals 3A.
Yeah. And there's our second equation.
Okay.
And now there's numerous ways to solve this.
Yeah.
You can solve it by solving for K and substituting. In other words, K equals 3/2 A. Now I can go substitute 3/2 A for that K there. So I get A minus 150 equals 1/3 times 3/2 A. Well, conveniently, the 3's cancel out.
Yeah.
And I get 1/2 A, or A minus, add that 1/2 A to the other side. I get 3/2 A equals 150. Excuse me, I don't get 3/2 A. I end up with 1/2 A over here, so I got to subtract that. So I have 1/2 A equals 150. A equals 300. And if A equals 300, K is 3/2 A. No, in fact, do we need both variables? Sometimes it's real easy to get caught up. Yeah, we do. Okay.
Yeah, because I think you have to add them both.
Right. It's easy to get caught up in solving for something, and you look back at the question and you don't really need to solve it. So yeah. This is 450. So 450 plus
so
300, 750 is okay.
750.
Yeah.
Okay.
And notice why that was not a good back solving. That is almost the textbook type of question that you can't really back solve.
Yeah.
We would have to take this number and split it up in an infinite number of ways almost in order to try to back solve it. And that's not easily done. Not that this problem was easily done algebraically either, but easier algebraically than it would have been back solving, and I'm quite certain.
Okay. So 28. What is the solution set for x for the inequality 2x plus, or the absolute value of 2x plus 7 is greater than 11? Would you split it into two?
Yes,
kind of
always.
things?
Whenever you see this, you got to split it into two inequalities.
So 2x plus 7 is greater than 11, and then 2x plus 7 is less than negative 11.
Solve each one.
So then it would be, for the 2x plus 7 is greater is 2x. It's greater than 4, so x is greater than 2. For the other one, it's 2x is less than negative 18, and x is less than negative 9. So then the answer would be negative 9, 2, so it would be k.
Good. Okay, the distance formula, another classic from algebra that you want to make sure you can do. Always be able to do the distance between 2 points.
Okay, so isn't that the square root of x2 minus x1 squared?
Yep.
And then plus y2 minus y1 squared.
Correct?
So that would be the square root of... Yeah.
Little different, but says the same thing.
Okay.
Notice that it doesn't matter which way you go, and that's one of the reasons I write it like this. There's no reason to memorize it with all those things in it. Because it can either be x1 minus x2 or x2 minus x1, because when you square it, takes away the relevance of which one you started with. So when you write delta x squared, you're saying, what is the difference in the x coordinates? Whatever they are, I'm going to square it.
Yeah, that's true.
In other words, you don't have to get all caught up in the signs.
Yeah.
What's the distance between minus 2 and positive 1?
So if it's... Wouldn't it be 1 minus 2 squared.
Yeah.
So 1 plus 2.
But more importantly, this is what a lot of people don't like to do, and I'm not sure why. In other words, I don't care if it's 1 minus a minus 2 or minus 2 minus 1, because I don't care what the sign is. The only thing I care is that it is 3 units between those two. Because whether it's minus 3 or 3 matters not. I'm going to square it anyway.
Oh, yeah.
So rather than trying to remember the precise arithmetic, not that that's a bad thing to know, you definitely need to know how to subtract a negative number from a positive number, but more importantly is all we really need is the distance between those two numbers. What's the distance between 4 and negative 2?
So if it, that would be nice to draw. So 4 and negative 2 is 6.
Okay. So we're going to square that. So we're talking square root of 45. Which of those answers is square root of 45?
3 root 5.
Yeah.
Okay.
Okay. You see what I'm trying to say on the number line?
Yeah.
Yeah, and it's not like you need to worry about whether 0 counts as a number or not. In other words, when we were going from 4 to minus 2, with 0 being there, you know the answer is 6. What you might not realize is whether it's 6 or minus 6, but it does't matter. It's 6 units between there. And that's something you should be able to come up with almost instantly. If I give you a negative number and a positive number, you want to know how far it is between them.
Okay.
Okay? Without having to resort to the rules of arithmetic.
Okay. So 30. Yeah. So if log base 5 of x equals 2, what is the square root of x? So swoop thing. So if log base 5 of x equals 2, doesn't that mean 5 squared equals x?
Uh-huh.
Trying to remember this. And then, so if the square root of x equals, so it would be the square root of 25, and then that equals 5.
Right.
So f.
Uh-huh.
Okay.
31. Let me move it over a little bit. There we go.
Okay. Okay. So if PQ plus 12 equals 3P plus PR, and Q minus R equals 7, what is the value of P? Ooh, so, well, can we isolate I would want to isolate Q and R.
Well, hold on a moment. Let's realize something when we look at that. How many variables do we have?
1, 2, 3, 4, 3.
Okay. We only have 2 equations.
Yeah.
So we can't always solve for P. So there must be something very special about this that allows us to solve for P. Because we wouldn't normally be able to. There must be a Q minus R in this. In other words, if we manipulate that enough, we should end up with a Q minus R.
Okay.
Okay. So that's my thinking. I haven't bothered to work through this yet, but
yeah.
Well, let's see. How could we get a Q minus R? That's going to be our goal, is can we manipulate that equation so that we end up with Q minus R, which we could then replace 2 variables with a number. two of the three variables. If we can replace two of these three variables with one number, we'll only have one variable left and we'll be able to solve it.
Yeah.
So let's manipulate that thing so we get a q minus r somehow. What would you do?
Can you, I was thinking p, so I was just thinking of the normal equations first, so pq plus 12 equals 3p plus p, or no, yeah, equals 3p plus pr. And then I would remove I would take the pr to the left side.
Okay, that's what I was looking for. In other words, if we get this, I can see that that's going to result in a q minus r when I factor a p out.
Yeah.
That's why I would do it. Okay? And let's go ahead and write the plus 12 equals 3p.
Yep.
And now let's factor the p out. So we have p times q minus r plus 12 equals 3p. We can replace that with a 7.
7p.
So now we have 4p equals minus 12, p equals minus 3.
P equal, yeah. Yeah, that's A. Okay.
Now, I love this question, but how many different ways there are to do it, I don't know. There's probably a few. In other words, we could probably solve that for q. It would be equal to 7 plus r. I then substitute 7 plus r for q. It still depends on getting rid of that r over there, which probably does end up canceling out. But I think this concept here of looking for a q minus r is an important one.
Yeah.
All right.
Okay, so 32. So, let's see. First workout, Anthony did 30 push-ups. And on each successive day, he did exactly 3 more push-ups than the previous day. After completing his push-ups on the 30th day, how many push-ups had he completed on all 30 days?
So it's what series?
So wouldn't it be 30, 33, 36, 39? So it'd go up by 3. It'd go up by 3. So then...
Got some nice questions on this test. I like them. They required a lot of thinking.
Yeah, so...
I'm looking for an easy way to do this. Do you know
I
the
was
hard...
going to fill out the whole chart.
Okay, well that's
Yeah.
the hard way. The hard way would be to figure out what the 30th term is.
Yeah.
What's the general formula for an arithmetic series?
For an arithmetic, I'm trying to...
This is arithmetic because every term is separated by a constant.
Yeah, it has the same number.
Right.
Kind of add to that.
That's why this is the hard way, is because it requires you to know this by memory.
Oh yeah, I remember that one.
There's the general format.
Okay.
Okay? So we also have another one that is the sum of the first 30 terms, which is what they're looking for.
Oh yeah.
That's equal to n over 2 times a sub 1 plus a sub n. So we can use this, but in order to use it, we need to know what a sub 30 is. We need to know how many push-ups he did on the 30th day. So let's figure out what a sub 30 is.
Okay.
What is it?
Shit, give me a sec.
Okay. If you plug it in to this general form.
Oh yeah, that's a good idea. 8 sub 30 equals 1.
No, it's the first term. What's the first term of this series?
So it'd be 30. plus, and then n minus 1.
Not 10.
Be
30 minus 1.
So, yeah, so 29, then times 3.
Okay. So what is that?
So,
That looks like 87 plus 30, 117.
yeah.
Okay, now we know what n is, we know what a sub 1 is, and we know what a sub n is. So we can plug it into this equation. After we're all done, I'm going to find an easier way to do this.
Okay.
Because I'm a little amazed that they expect you to memorize these two equations. That's almost asking a little much. So
Yeah.
our 30th term is that.
Mm-hmm.
So what's the sum going to be?
So 30 equals, would you plug in n for,
No, n is this, always that.
okay, so, oh, the number.
Yeah.
So plug in, so 30 over 2 plus
Times.
times 30 plus 117.
There you go.
Okay.
And that is the answer. So it's 15 times 117. I bet we don't need a calculator. Let's see. By my it's the second problem we've had where you have to multiply something by 15. So the answer must be that plus half of that, which is like 500. Answer's got to be J.
Okay. 150,
Yeah.
1500, okay.
No, that was a lot of work. There's got to be a shortcut way to do that, especially since they're only looking for approximate. Huh. Let me gander at that for a little bit without knowing what that number is. Well, let's see. First of all, we know we're going to have 30 times 30, correct?
Yep.
In other words, the initial 3 is the same. Oh, no, it's not even that. It's much more than 30 times 30.
Wait, this 30 times...
Well, because it doesn't take you long to get out of the 30s. In other words, we get to 42 real quick there. However, if there was no increase at all, in other words, if you did 30 push-ups on day 1 and 30 on day 2, that would be 900 push-ups. So, if you were guessing, you would certainly eliminate F, you would eliminate G,
Yeah.
because clearly we have a whole lot more than 30 on each one. We got an extra 3, 6, 9, and so forth. We got that whole series. If I was guessing, I'd either guess J or K. I can't think of you might be able to think of another way to do this problem.
Yeah. Trying to think, but
well, here's a clever one. This is a problem that Gauss, one of the greatest mathematicians of all time, was asked by his math teacher when he was 8 years old, which was, what are the sum of the numbers between 1 and 100? He came up with the answer in 10 seconds.
sum of... I can't get that in 10 seconds.
I can almost, well, he didn't do it using this formula. At least I don't think he did. Who knows? Maybe he was so smart at 8 years old he knew that formula. What he realized was that when you add the numbers between 1 and 100, you can add those, and then you have 2 and 99, and you can add those, and you end up with a bunch of pairs that all add to 101.
Oh.
Until you get to the middle number in that series, which is 50, and 51. There's the inside pair. So what Gauss realized that he has 50 pairs of numbers that add to 101.
That's really cool.
That is the sum. At least I think it is. When I was doing this question, this is the way I did it. In other words, when I was trying to figure out what the sum of the first 100 numbers are, this is the way I did it. And I'm thinking that that's probably the way Gauss did it also. Now, can we apply that to this problem is the question. Perhaps. What's the middle term in the series?
15.
Well, it's the 15th times 3, right? So 45 plus 30. It's got to be 75, I believe. In other words, if this is the first term, and that's the second, that's the 15th, and there's some 30th term over there. So the problem with doing it this way, aha, there is a shortcut. We don't know what that 30th term is, but we know that the final two are going to be 15 and 16, the final pair. In other words, hold on, let me think about this for a second. Not 15 and 16. The two middle terms are going to be 75 and 78, which are the 15th and 16th terms. Remember when I did the 100? Oh, I erased it all. We paired up 1 with 100, and then we got down and paired up 50 with 51.
Yeah.
The sums were always the same. So if I pair up the 15th and the 16th terms, which is 75 and 78, my sums have to be 153. Now I know my 30th term. I don't even need to know that. I know I have 15 pairs that all add to 153. That is 1530 plus half of 1530.
Oh.
Hold on. I did something wrong. What did we figure our 30th term was? 117? What does 30 and 117 add to? 147. Ah, it's 72 and 75 that are the final pairs. The 14th and the 15th terms, not the 15th and the 16th. No, I don't know that it matters. Did it? Did I get the wrong answer? I think I did. Hold on a second. So it's 15 times 147 is the answer, which is 1470 plus 735. That's 2205. How did we get the first time?
I think we added the 30 and 117 wrong. I think we got like 145 when I'm looking at.
Right?
Yeah, I think in the first, I think we got 145.
Well, I think what I did wrong was I didn't do that multiplication correctly. In other words, I ended up with 15 times 147. It's just that when I multiplied it out, I got between 1,500 and 2,000 instead of clearly greater than 2,000.
Okay.
Okay. That is another way of doing this. It's perhaps harder and more complicated. It's just easier to know the formula. But it is another way to look at the problem. And it's another way to look at arithmetic series.
Yeah. Okay. So 33.
Yeah.
So it's a quadrilateral with an angle. The other angles are labeled with a value of x. So if one of them's 90, and so the whole thing has to equal 360.
Okay, so what can I...
It would be 90 plus 2x plus x equals 360. So then 90 plus 4x equals 360. Then 4x equals 270. And x equals
It's the only
somewhere in the 60s.
Exactly, and that's all you need. If you
I
look
think
at
it's a little. It's more than 60, so it has to be the 60s.
if you look at the answers, that's all you need.
Okay.
In other words, the moment you realize it's greater than 60 and less than 70, you have the answer.
Okay.
Let's see, did we do all the ones on the right side? And skip?
I think so.
Yeah.
Okay, so 34.
Might be a little bit more challenging than the ones I have digitized.
If a cube has a volume of k centimeters cubed and a surface area of 10k, what is the height? What is the height in centimeters? So trying to think, can you use k equals
Well, what's the volume equal to of a cube?
so
Always try to find the general formula of the equation that is going to apply. What's the volume of a cube equal to?
isn't it just, let me try to remember this, sides, no, not sides cubed.
Yeah, sure.
Oh, it is.
Yeah, it's the side cubed. Okay, what's the surface area of a cube?
That I don't know that one.
Well, let's figure it out. How many surfaces does a cube have?
It's hard to imagine.
Well, think of a dice.
Yeah, I'm not very good at that kind of stuff. I'm kind of picturing.
6. Here, let's draw one.
Okay. So that's kind of my weak thing. It's hard to imagine
I
stuff in my head.
understand. I understand perfectly what you're saying. I always had a terrible time with three-dimensional geometry. But we've got that side, that side, that side, and they're equal and opposite sides, and that's it. So 6.
Okay.
What's the area of each side?
The area? I was going to say 10.
No. In other words, looking at this picture, S is the side length. Remember, a cube only has one measurement. Its side length. Okay, so the surface area must be 6s squared.
Yeah.
Okay, so those are the two fundamental equations that apply in this problem. Okay, and these are two you want to know. You want to have these memorized. That the volume of a cube is s cubed, and the surface area is 6s squared.
Okay.
Notice when they say they're after its height, well, what is the height? That's s, isn't it?
Yeah.
Okay, so we can also say that s cubed is equal to k, because they tell us the volume is k,
Yep.
and they say the surface area is 10k.
Oh. So you can say 10k equals 6x, or 6s cubed, or squared.
Well, yeah, let's substitute k it's the easiest one to substitute. So now we have 6s squared equals 10s cubed. So here's our master equation, and their answer is they want s.
Okay. So then you can make it 10s equal, or yeah, you can say 10s equals 6.
You can do that. You can do that only because you know s is not 0.
Yeah.
Okay. So 10s equals 6. What does s equal?
3/5.
And that's the way you do that.
Okay.
Well, that's 2 or 3 in a row where we had to know a master formula.
Yeah.
So if you're looking for stuff to memorize when you are preparing for these tests, those are good things to memorize. Those master equations for stuff like rectangles and cubes. Okay.
Yeah.
Here.
Ooh, so I'm going to read the question. Okay, so then n equals, I've done one of these a little bit ago actually. So what I'm thinking of doing is, you could put...
Notice that back solving isn't going to work very well.
No, it's
because
not.
these are all, if we look at our answers, there's no whole integers there.
Yeah.
So clearly we're going to end up taking 8 to a fractional exponent. So back solving is going to be fairly difficult. I guess we could do it with the aid of a calculator, but it's not going to be easy.
Yeah. So I was thinking you could do 2 to the 3rd.
There you go. That's the
n minus
That's
n
always
minus
what
1.
they want whenever you see a problem that the two numbers have a common exponential base, always be thinking that. How can I write square root of 2?
2 to the 1/2.
Now what?
Ooh, 2 to the power of 3 times n minus 1.
Okay, so that's 3n minus 3. In other words, you multiply those two exponents together. When you're combining. Yeah, when you're combining them.
Yeah.
Now what?
Well, since they're both the same bases, you can pretty much cross those out.
Right, you can equate their exponents.
Yeah.
Oh, we get this.
Yep. So then 3n equals, let me do some 7 over 2.
I added 3 to both sides, so I had 3.5, which is 7/2. And then I can divide it by 3 easy enough.
Okay.
You know, it might not have been that hard to do with your calculator. I'm sitting here thinking, in other words, you would have to take your calculator and calculate 8 to the 1/2. Well, we can throw that one out immediately, right? In other words, if we try n of 3/2, that clearly isn't the solution. That's not equal to square root of 2.
Yeah.
Okay, and then if we were going to do 8 to the 4/3 minus 1, that clearly isn't the solution. That's 2.
Yeah.
So you might be able to get somewhere. Then we would take 8 to the 1/4. That I would have thought was the answer myself, because I would have taken, no, you want to take the, boy, that's a little delicate. Yeah, it's 8 to the 1/6 equals the square root of 2. Okay. Now the best way to do this problem is the way we did it.
Okay.
You could do it by back solving. If you couldn't figure out that first way, you would, if your life depended on getting the right answer, you'd just plug in all 5 into your calculator and see which one is equal to 1.41. It's nice.
Yeah.
It's nice knowing that the square root of 2 is approximately 1.41. That's also very worth knowing, and that the square root of 3 is about 1.7.
Okay.
Okay.
Okay, 36. And is the midpoint of AB. Which of the following answers choices are the coordinates of n? Okay, you could just use the midpoint formula.
Yes.
So that's x1 plus x2 over 2,
Okay.
and y1 plus y2 over 2.
Okay.
So that would be negative 3 plus 6 over 2, which is 3 halves.
Okay.
And 0 plus k over 2, which is k over 2. And doesn't think we have to solve for k at all. So.
No, that's answer J.
Yeah.
And, you know, it's almost worth noticing something here. If we look at the answers, notice that there are 3 answers that have the same x-coordinate.
Yeah.
That's almost 100% got to be the x-coordinate.
Yeah.
You see?
That's true.
Don't you think? At least that's what I
Yeah.
do.
I always do that during tests.
It's not impossible that could be the answer, but it's most likely one of these 3. So it does a little bit of the work for you, if you notice.
Yeah, because if it wasn't, then you could just point out 2.
Yeah,
there's
exactly.
only 2 answers left.
Right, exactly. If it wasn't 3 halves, then you don't even have to solve for the y-coordinate, because either the answer is going to be 3 or k over 2. And it would make the problem a lot easier. So there's some assumptions that go with that. And maybe that's a little dangerous, but if you're pressed for time and you don't want to figure out what 6 plus or minus 3 is divided by 2, you can be pretty sure it's 3 halves.
Yeah. So 37. So if a over b minus c over d equals 0, and bc equals 7, which of the following statements must be true? I was going to do like an equation kind of thing for it.
Yeah, that's fine.
Okay. So I was thinking it would be, so that's that equation, so it would be a over b equals c over d.
There you go. That's what I would have done. That's what I had just done in my head. Okay.
Yeah. So then AD equals BC. So now so BC equals 7. So then AD equals 7. So I don't know what to do after.
Okay.
I know those.
Look at all of the answers have to do with direct or inverse proportionality. If I said y is directly proportional to x, what would you write?
Well, I just don't know what that like. Kind of. Yeah. I don't know what inversely means. Kind of like.
Okay. There's direct proportionality. Y is equal to some constant times x. Direct proportionality means that when x goes up, y goes up. When x goes down, y goes down. Inverse proportionality is the opposite. That would be y equals some number over x. In which case, if x goes up, y goes down. If x goes down, y goes up. Hence the name inverse. Okay, that's one way to memorize it. So, what does that translate to? And which 2 letters? In other words, it actually tells us the answer based on the only combination of letters that we can see we have left.
Oh, so let's see. Oh, I didn't really look at that.
And notice that A is equal to 7 divided by D. That makes A inversely proportional to D.
Okay.
This K is just some number. We don't usually know, but in this case we do know. It's 7.
Yeah.
Now, we didn't know for sure we had the right 2 letters there. In other words, we were just solving these equations and canceling out the BC we had with a 7, so we got down to this equation. So saying that C is the answer based strictly on the fact that that's the last 2 letters we have left is probably a little dangerous also.
Yeah, that's true.
But once you recognize that that makes A equal to 7 over D, and that is the definition of inverse proportionality, then you can more comfortably pick C as an answer.
Yeah.
All right, let's do one more, 38.
Okay.
These are good. These are really a good test. I'm going to hold on to this test and use it with other students.
It's pretty good.
Well, they're hard. They're very challenging, thought-provoking questions.
Yeah. So the following figure, the area of the shaded is 10%, and the area of the circle, 10% of the area of the circle. If the radius of the circle is 10, what is the arc length of P and Q? Ooh, so can't you use the radius for the circumference then?
What are the 2 primary general formulas for a circle that I want to write?
Well, you can do circumference equals 2 pi r.
That's one of them. The other one is area equals pi r squared.
Yeah.
Okay. So the fact is, the radius of the circle is 10, so I can figure out the area or the circumference. What's the circumference of the circle equal to?
2 pi 10, so 20 pi.
What's the length of that arc length? Hold on a moment. No. That's bad logic. That's bad logic. I picked a bad last problem to do in under a minute, and that's all right. Let's stay on this. We're almost there. So the circumference is 20 pi.
Yeah. Oh, I think I get what they're saying. I think I know what to do.
What's the answer?
So, since the area of it's 10, I was thinking, so it would be P to Q would be 10%. So then...
Unfortunately not, because P to Q is a linear measurement, and area, in other words, here's what I'm trying to say. If I have a circle with radius 2, and I have another circle with radius 4, the area of this circle is 4 pi. The area of this circle is 16 pi. Yet the circumference of this circle is
But isn't it just
4
for the
pi.
shaded region?
Hold on, one moment.
Oh, sorry.
Notice the circumference share a 2-to-1 ratio. The areas share a 4-to-1 ratio. So that's why the logic is a little flawed, that that's not going to be just 10% of 20 pi. Because the area is 10%. So what would that make the circumference? Less than that or more than that? Let's see. In other words, what is the relationship if this is a 1 then that is 1 pi area, and this would have to be a 10 pi area. What would its radius need to be for it to have an area of 10 pi? It would have to be square root of 10. So the radiuses have to share a square root of 10 to 1 ratio.
Okay.
I want to give you the wrong answer without thinking about it a little bit more. I do need to run. I have another session. Let's pick up with this problem next time. This is a good problem. This is really a
I'll definitely try to do it too. So
I think the answer's got to be pi, but not positive.
I just don't know because it's the. I would think it's because of it's the shaded region, but I don't know.
Well, no, I was going to do exactly what you did, which was, well, that's 10% of that, therefore that has to be 10% of that. But they don't share that relationship. In other words, that ratio isn't the same. Once you go from 1 dimensions to 2 dimensions, when you go from circumference is unidimensional, area is square dimensional.
Oh.
So it's not going to have that 10 to 1 ratio. It's going to be a square root of 10 to 1 ratio, which makes the area, I can't put my finger on it at the moment. We'll pick up on it next time.
Okay, that's fine.
All right.
Yep. I'll see you then.
Talk to you then.
Yep, bye.